Not too long.
I cannot find the problem. For some reason, I think I lost this. Oh, I found it. And I lost my notepad. I tried to get it. Oh, yeah, this should take long.
So what we're looking at and continuing on is the sum and difference of two cubes. Now the first step is determining if both of these are indeed perfect cubes. Now one of the ways that we kind of know that we're dealing with a sum or difference of two cubes is that we will have two terms, and both of them or one of them will have a variable to the third power. Now it is always helpful to make sure that we don't have a greatest common factor. There's not a number that will go into both terms. But here there is no greatest common factor. And so we can see if x to the third is a perfect cube and if 125 is a perfect cube. And what I always start off with is finding the cubed root of both terms because we can find out what's going to take the place of a and b in the general form. Now the cubed root of our x to the third is, well, just x, because the cubed root and third power will cancel each other out. Now the cubed root of 125 is 5. Now we can take the calculator and do 3 second our x root. So it's the button above the one we use for square roots, and that 3 should get a little bit smaller. And then we can type 125 in and see what we get. So we got 5. Now a way to check it is to take 5 and put it to the third power and see, do we get back to 125? Multiplied 5 by itself 3 times, we do get 125. So what that tells us is that these are a difference of two cubes, or a sum of two cubes. Both terms are perfect cubes. Questions on this here? Now, since x came first, it's going to take the place of a. Since 5 came second, it will be taking the place of b. Now, to set up our form, we'll still have two sets of parentheses. The first one is going to have 3 spaces, and the second one's going to have 5. Now the first thing we're going to focus on is the signs. Now our signs are going to be the same, opposite, always end on a positive note. So our starting sign in the problem was plus. So for it to be the same, our first sign is going to be plus. Opposite means we're going to change it from positive to negative, from a plus to a minus, and we always end on a positive note. So for this here, it's going to be plus, minus, plus. Same, opposite, always end on a positive. And I throw a pin. Questions on this so far? Are we ready to start plugging our terms in? Let's focus on the smaller set of parentheses first. So our first term, the one that goes in the first spot, is going to be dealing with our cubic of our first term, which is just x. The number that goes in our other spot for this first one is going to be the one taking the place of b. Just x and 5. Questions on this here? Now the bigger one, I'm going to write it this time really after this. I said this yesterday, we're not going to put the 0 powers, but I'm going to put it there just so that we can see them. We're going to start off with our first term, this x. Because when we plug it in the first spot is going to be to the second power. In the middle spot is going to be to the first, and in the last spot it's going to be to the 0. So the first term's exponent, and our bigger set of parentheses is going 2, 1, 0. Question on how we got that there. So the powers for the first term is going 2, 1, 0. It's decreasing. The second term is increasing. So it's going to go 0, 1, 2. 0, 1, 2. And this is one of the nice things about the sum or difference of two cubes, is that it has this nice pattern to it, that no matter what the two terms are, as long as we have two cubes, it will work like this every single time. It's not that we're drawing a guess and check. This is how it works, which is nice. Now, the last thing we have to do is to simplify. Now, luckily, our first set of parentheses, that x plus 5 is just going to be x plus 5. Our second set of parentheses, five to the 0 power is what? 5 to the 0 is 1. Anything to the 0 power is 1. So really this here is 1. Now if we look at this here, so we said 5 to the 0 is 1. X squared is what? X squared, yes? What's 1 times x squared? X squared. This is part of the reason we don't necessarily write out the 5 to the 0, that second term to the 0 power, because it becomes 1 multiplied by our first term is just going to be that first term squared. So we don't necessarily have to write the number to the 0. I put it in here and I put it in the last one just to see that mental picture. We're going 0, 1, 2, or 2, 1, 0. Let's look at the middle term. Well, x to the first is just what? X. 5 to the first is. So really, what do we have? 5 times, which is 5x. 5 times x is 5x. So do we really need to write those first powers? No. But again, I'm putting there so that we can visually see what the exponents are doing, how these terms are working together. Now, if we look at the last one, well, just like we said already, x to the 0 is really just 1. So we look at this multiplication. Here, our x to the 0 is just 1. What's our 5 squared? 25. So what we have is 1 times 25, which is 25. No cheat from yesterday. Yes. Questions on how we did this here? Are you ready for the next one? X cubed minus 64. So here, there's a good chance we have a difference of 2 cubes. The big giveaway is that we have x to the third. No greatest common factor between these here. So we're going to take the cubed root of both to get our values that are taking the place of a and b. The cubed root of x to the third is x. Cubed root of 64, well, grab the calculator and go 3. Cubed root 64 is 4. So it's telling us that 4 times 4 times 4 is 64. So that does verify that this is a difference of 2 cubes. Our signs are what? Same, opposite, always end on a positive note. So for us to have the same, the first sign is going to be a what? Negative. Since we start off with a difference, our first sign is negative. Second sign's opposite, so we're going to flip it to positive, plus. Always end on a positive note. Means our last sign is plus. Questions on our signs? All right. Time to plug our first terms in. So with the set of parentheses here, in the first spot, we'll put our singular value for our first term, which is just x. In our other spot, we'll put our b value, which is 4. So for this here, our first set of parentheses is x minus 4. Questions on this here? In our bigger set of parentheses, we'll start with our first term, which is x. So in the first spot, we'll have x to the second power. In the middle, we have x to the first. And in the last spot, we really have x to the what? 0. But anything to the 0 power is 1. Multiplication of 1, we don't have to write it. Questions before we move on to our other term? Yes. So it's the reason that we do the signs the way we have them here is based off the starting problem. So since this here starts off as a difference, the first sign is always going to match it. First sign is going to be the same. Since we start off with minus, our first sign is minus. Then we have the opposite for our next thing, plus, and we always end on a positive note. So it's always going to end on a plus. And part of that's due to the properties of how we need this to multiply out to get our signs. Because that first one's going to be our negative. Now, especially with our constant term, the term without a variable, or that last term, for it to get negative, it needs to be positive and the other needs to be negative. But if that's a little confusing, it's not necessary. Because we could go deeper in it, but I don't want to confuse y'all too much with it. We ready for the other term? Our number that's taking the place of b. Now with the x squared in that first spot, we would really have 4 to the 0. We don't have to write it. In the middle, we have 4 to the first, and in the last one, we have 4 squared. Questions on this here before we start simplifying? So the first thing we're going to simplify is our x to the power of 2, x squared as well. X squared. X times x, x squared. In the middle, we have x times 4, which is 4x. Plus, last one's 4 squared is 16. X minus 4 times x squared plus 4x plus 16. That's it. Questions on this here? Now again, it's always good to look for a greatest common factor between our terms. 27a to the third, 64, they both don't share a common variable. And if we're looking for greatest common factors between 27 and 64, so we could see 9. 64 divided by 9, 3. Because the three that I would be, main ones I'd be checking are 3, 9, and 27. Because those are all the factors of 27 other than 1. They don't share a common factor. So we can check cubed roots to see if these are perfect cubes. Now the 27 a to the third, well, the cubed root of a to the third is a. Now the cubed root of 27. 3 cubed root 27 is 3. Now when you're doing the cubed root, one thing I'd make sure, because we're going to go 3, second, make sure that that 3 does get a little bit smaller. It does go into that index. Because if we did this here and typed in 27, we get 9 square roots of 3. Not the 9th root of 3, because it took the square root of 27, not the cubed root. So it tells us that 27a cubed, the cubed root of it is 3a. What times itself 3a times is 27a cubed? That'd be 3a. Cubed root of 64, 4. So that tells us that this is a sum of two cubes, and our two terms that we have are 3a and 4. But before we start working with those, let's put our terms, our signs in. And the signs are going to be the same. Opposite always end on a positive note. So for it to be the same, our first one's going to be plus. It's going to match what we have. Opposite, going to flip to minus, and always end on a positive note. So here we have plus, minus, plus. Let's look at our first term, 3a. In the first spot, in our smaller set of parentheses, it's going to be 3a. Our second term in our other spot is going to be just 4. And that first one, we just have 3a and 4. We just put those two terms in. They're to the first power. We don't have to do anything to them. In the bigger one, we'll start with our 3a. And our first spot is going to be to the second power. In the middle, it's going to be to the first. And the last one, it's technically to the 0, but we're not going to write it because it's going to become 1 and multiply out, or simplify out. 4 with the 3a to the second power would be technically 4 to the 0. We don't have to write it. In the middle, it's 4 to the first. And then the last one, it is 4 squared. Now, out of all this here, the easiest thing to simplify is our first set of parentheses, because it's just going to say 3a plus 4. In the second set of parentheses, the first thing we're simplifying is the 3a squared. So we're squaring it, we're multiplying it by itself, yes? Now, one of the nice things about this is there's no addition or subtraction sign in there, so we can just square both terms, because we're saying 3a times 3a. Well, 3 squared is what? A squared is a squared. Because really all we're saying is 3a times 3a. 3 times 3 is 9. A times a is a squared. So 9a squared. Minus 3a times 4. 12a, yes. And lastly, our 4 squared is 16. And again, just as a reminder, that quadratic part, the 9a squared minus 12a plus 16, will not factor. Because one of the giveaways that there might be possible factors, or it could factor, is if we have that a squared a variable to a power. But here, the quadratic part does not factor. All right. I'm starting to get the hang of this. Oh, out of this here, the cubed root of x cubed is going to be x. The cubed root of y cubed is going to be y. Now we need to find out what the cubed root of 192 is. Do we have a cubed root for 192? No. I have a feeling we don't have a cubed root for 81. Okay, let's go back. Is there a number that can go into both? So 192, there's a few. But how about 81? What are some numbers that go into 81? 9. Okay. So 192 divided by, try that again, 9. Okay, it didn't go into it. 82 divided by 81. What other number could go into 81? 3. So these two numbers have a greatest common factor of what? 3. So if we take 3 out of 192, we have 64 x cubed. We factor the 3 out of 81, we have 27y cubed. So sometimes we got to take that greatest common factor out to get what we need. So now, well, now we're looking at the cubed root of 64 and 27. Well, the cubed root of 64 is 4. Cubed root of 27 is 3. Because luckily we've had these two already today. Our signs are going to be the same, opposite, always end on a positive note. So the same minus, opposite is going to be plus, always end on a positive note is going to be plus. So let's deal with our first term, our 4x. So we have 4x, and then the other spot we're going to have 3y. Now filling in the bigger one, in the first spot we'll have our 4x being squared. Then it's going to be to the first power, and the last spot it would technically be to the 0. When we fill in our 3y for our squared first term here, it's to the 0, so we don't have to write it. Our middle term, it's to the first, and in our last term, it's being squared. We still need the 3, and our 4x minus 3y really doesn't simplify further than what it is. Now we do need to do some simplifying in our other set of parentheses. The first one we're simplifying is 4x squared. So if we square 4x, so 4x times 4x, 4 times 4 is 16. X times x is x squared, telling us that it's 16x squared. Our 4x times 3y, our 4 times 3 is 12, and then we have xy plus 3y squared. 3y times 3y, 9y squared. And that's it. Questions on this here? Questions on anything we've done so far? So did adding the variable y into this change anything? No, it's the same thing. That's what's nice about this. Unlike the others, factoring quadratics where there is that guess and check element, this is following that set pattern every single time. Let's skip this one and look at this one. Because if you want because the answer for this here is going to be x minus 3 times x squared plus 3x plus 9 is how this one's going to factor. But let's look at this one here. So we want to see if we can take the cubed root of our first term, 125, which is 5, and our cubed root of our second term, which is x cubed, would be x. Now this one is a little different because the variable is not going first. It doesn't change how it works. We can still leave it in the second spot. It will work just fine. Cubed root, well, we'll do our signs first. Our signs are going to be the same, opposite, always end on a positive note. So minus, plus, plus. In our first set of parentheses, we put our first term and second term in there. So the first term is going to be 5. And our second term is going to be our x. Then we'll do the same with our bigger set. The first term, our 5 is going to be squared to the first power, then to the 0 power. Our second term is going to start off with the 0 power here. We don't have to write. To the first here. And lastly, to the second. And the last thing we have to do is simplify. So we still have 5 minus x. Our 5 squared is going to be 25. Plus 5 times x is 5x. Plus our x squared is x squared. And that's it. Now if we want to write our quadratic expression in standard form, we can. We don't have to flip it. You can leave it in the other version. Both of these are the same answer. Now, especially when we get to solving rational equations, it's going to be helpful if we rewrite it as flipping those two and making that x cubed positive. Still possible to factor it this way, but it does make it a little bit nicer if we have it the other. Yes. Questions on this here? And that's it. Your homework is going to be another worksheet.